Okay, when you are on one of these panels, you never know how much time you're going to have, so I thought I'd put the bottom line up front. You know, when the first, Flaxman and Hans announced their discovery or had the meeting, they were immediately challenged, where are the neutrons, where's the radiation? Oh, by the way, if you're really producing as much heat as you claim you're producing, your graduate students would all be dead. They aren't dead, therefore you aren't doing nuclear reactions. Well, things have changed since then. In addition to the anomalous heat that was produced, multiple linear experiments using different experimental protocols in different labs, in different instrumentation, have detected the presence of anomalous radiation, including charged particles and neutrons. Now, it's true it's much lower flux rate than the radiation that was expected, but that doesn't negate the fact that radiation was produced and in fact indicating nuclear reactions. And clearly additional experiments and theoretical developments are required to understand this, and I've heard several things, presentations at this conference that are encouraging. Okay. I thought I would just, George Miley put together a chart of labs reporting transmutation. I've used that many, many times in presentations that I've given. I thought I would put together something that makes the point that I made earlier. This shows, that where the experiments were, the group that did the experiments, the country, and you can see here the type of experiment, whether it's gas loading, electrolysis, co-deposition, all the way down, what radiation was detected and what the method of detection was. So you see from BF3 to liquid scintillation, proton recoil, silicon surface barrier detection, helium-3, and so you can see a wide variety across a wide variety of groups. Here's another chart continuing this, and by the way, I'm sure I've left people out. These are representative. If I've left you out, I apologize, but you can see again from Japan, USA, Germany, Russia, China, and finally I've got down here the work that we've done in San Diego, where tritium charged particles and neutrons using liquid scintillation and CR39. Here are some examples of data. This one were in the presentation that Srinivasan gave earlier this week, and from his lab. Here's one from Ed Storms, Los Alamos, using liquid scintillation. This one is from Rozetsky, the Russian Academy of Science. Lipson up here. This one is Rozetsky at the Lebedev Institute, showing the triple tracks and CR39. A wide variety of sensors, a wide variety of particles that were detected. This is our work, probably some of the most recognized work. This in 2008, we did experiments that we thought looked like we were producing triple tracks. You can see the triple tracks here. We compared those triple tracks with what was written in literature, things that showed in literature, and published a paper that actually came out in 2009 saying it looks like we're producing triple tracks, which are indicative of DT fusion. Following that, we decided, I knew some people that were involved in work as a contractor for DOE that had a DT fusion generator, so they could produce 14.1 MeV neutrons. So I contacted them. They said yes, they would be happy to expose some CR39 for us. So Larry and Pam went up to Santa Barbara. They exposed the CR39, and when we etched it, we got triple tracks. Now I'll let you guess which side, the left or the right. Which ones do you think are the real, and which ones do you think are the ones for well, they're all real. Which ones do you think are the ones from our cold fusion cell, and which ones from the DT generator? Well, it was a trick question, because this line was our co-deposition. This was examples from the DT neutron generator, another one from our co-deposition, and the DT fusion generator, you can see you really can't tell the difference. And so I think if you're going to use CR39 and interpret data and draw conclusions on CR39, you would have to conclude that these have all the appearance of DT fusion 14.1 MeV. And in fact, this quote from Johann Frege at MIT says, "I must say, data analysis seems to suggest that energetic neutrons have been produced." We published this data actually after we wrote up the second report, and we're getting ready to publish it, and I said, well, should we include the people at Santa Barbara as co-authors? So we called them and said, would you like to be co-authors on a paper? Send them the paper, and they said yes, they would very much like to be co-authors, but it would have to be reviewed by the DOE. So I thought, okay, let's see what happens here. So we sent it back to DOE. It came back about 3 weeks later and said, yes, they could be co-authors as long as in the acknowledgments we put the following statement. This manuscript has been co-authored by National Security Technologies, LLC, under contract with the U.S. Department of Energy. The United States government retains, and the publisher, by accepting the article for publication, acknowledges that the U.S. government retains the non-exclusive, paid-up, irrevocable worldwide license to publish or reproduce the published form of this manuscript or allow others to do so for U.S. government purposes. So, in addition to that, DOE required that they were going to put a copy of the article, give it a DOE number, and it would go into the DOE library. So I'm here to tell you that the DOE library is contaminated with an article that has neutrons generated by cold fusion cells. Just 3 months ago, on April 16th, we received a patent, and the title of that patent, in fact, David French is going to talk later today, and he will tell you that the patent office has said they will award patents in the area of cold fusion, and this is proof that the fact that is happening. Title is System and Method for Generating Particles. We did not hide the fact that this was cold fusion. I don't think we actually had those words in there, but it was very clear that this is what it was, and in fact, Pam, filed a patent in 2007, and it issued in 2013 after being bounced around several times, and in fact, about just late last year, after we had been told it would be issued, the supervisor there saw what it was and said, time out, and so we had to recycle, and ultimately they approved it, and we received the patent on the 16th of April this year. Now, we aren't the only ones. We actually had an earlier patent from the '91 time frame, but George Miley had one that filed in 2008 and issued, I think, somewhere here, there's date, 2012, and down here, this is a quote from from the patents that several tracks from CR39 after etching observed the tracks correspond to 1.7 MeV protons and 14.7 MeV alpha particles. So again, claims that we're producing particles and radiation, the patent office has allowed in the patents. The significance of the radiation, clearly the experiments are providing compelling evidence that nuclear reactions are occurring. At one time, I said irrefutable evidence in one of the papers we wrote, and I was challenged, and I decided, I realized that you can refute anything. The world still is flat. So I now use overwhelming compelling evidence. The low flux rates, and in fact, in Cerny Lawson's paper and others, we've seen publications where they're several orders of magnitude lower. I think 7 orders of magnitude lower than expected for neutrons is one of the numbers that people have obtained. That's good. I'm a mechanical engineer. I've said all along, give me heat without neutrons and radiation, and I love that. It's the physicists that have problems without neutrons. But so anyhow, this reduces the shielding and requirements. Now, Dave Nagel talked about flux rate the other day, and he asked me if I was upset with his presentation. I said, no, I can do the math. We aren't generating enough flux to be commercially viable now. But recall, they said the same thing about excess heat 24 years ago. And I don't think you would say that today. I think once we learn more about the theories, once we develop more understanding, who knows where this is going to take us. The low flux rates, in fact, suggest new and unidentified channels, including possibly an aneutronic channel exists. I may get my wish, heat without neutrons. And so that's clearly an exciting area for the physics group. And this should really be a fertile area for additional experimentation and theoretical development. And the potential here could be very, very significant. So, thank you.
We still have time for questions, please.
Do you have any comment about the reports of unusual radiations? For example, Dr. Storms reported that there was a radiation coming from at one of his experiments that actually activated his window, hit the window on his Geiger-Muller tube in one of his reports. I mean, the stuff that you were showing there was all conventional known particles and radiation photons.
I believe we've activated some things, haven't we? Yeah. So we have, some of our lead, I think, and you end up playing what's my line, because you get these lines and you start trying to match them up with what is expected, and when you go through that, you can't find what you're looking for, and then you start looking at the published data on potential lines, and ultimately then trying to figure out what could this possibly be. And I'm not going to pretend that we've been able to figure out what all those are, but we have seen some activation. Pam, do you have any comment on that, being the expert?
Well, we at one time we had over 160 lines identified. 160 lines that were unique. Of that, we identified, I think, about 30. So one of the things we've wondered about is whether we've got metastable states being created that have not generally been seen before, which is not surprising given what Graham showed earlier with these very, very slightly elevated excitations of the nucleus above the ground state.
Okay, thank you.